Welcome to ONO SOKKI's on-demand seminar. This startup seminar is for customers who are using OS-2000 for the first time. The OS-2000 we are going to introduce today is data processing software with a wide variety of functions. Let's get started. You will receive the installation CD and protection key drive. First, install the software. The icon of the OS-2000 shows on the PC screen when the installation is complete. Then, double-click this icon. The software will start. Make sure to insert the protection key drive to the PC before the start. If it is not recognized, the OS-2000 will not start. In such case, insert the key and start again. The OS-2000 has started. Let's import the data. Select Import Data File from the File menu on the menu bar and open the dialog box. Select the type of file to be imported. The OS-2000 can import various kinds of data files, including other companies' format. Change the files of type to WAV and select the file and open. The imported file is displayed on the Data Manager screen. Select the file, drag and drop it on the track display area of the main field. The time-axis waveform is displayed. For another easier way, open the data folder, select and drag the file. Select the file, drag and drop it on the track display area of the main field. The data import is complete. The OS-2000 can arrange different sampling data. Let's import new data. The two data has been imported. Drag these data on the track display area. This is a sound data recorded by sound level meter, and its sampling frequency is 64 kHz. The other is a vibration data. Its sampling frequency is 25.6 kHz. One is sound data. The other is vibration data, but taken from the same target. Check if the sampling is really different. Use the slide bar at the right bottom. Moving this bar to the right will enlarge the time-axis waveform. You can see each data has different interval. In this way, the OS-2000 can arrange different sampling data at the same time, and you can compare them. The OS-2000 can play back the sound while analyzing the frequency of sound or vibration data. Here, the sound data is displayed on the screen. Click L or R speaker mark and turn it on. The mark becomes yellow. It means the playback is available. Next, specify the playback range. Specify the range of data with Select Range button. You can listen to the sound over and over if Loop Playback button is on. Now let's get started. You can hear the sound like this. Let's examine the rattling sound in detail that you have just heard. You can change the playback speed. Generally, the sound is played at equal speed. Here, let's hear the sound played at 0.1 speed. You may hear the sound with lower frequency than the previous sound. First, play at equal speed. Then change to 0.1 speed. It sounds different. You can see two different sounds included when played at slower speed. Let's change the speed from 0.1 speed to equal speed. Now listen. Don't you feel like the two sounds are now easier to recognize when you go back to the original sound? When you would like to reduce the target noise like the rattling sound you just heard, the parametric equalizer is useful. Let us introduce. Open the project file made in advance. A project file can save the imported data and the display screen setting. This is the Parametric Equalizer screen. If this screen is not displayed, click Custom on the toolbar and select Parametric Equalizer. To display the time axis waveform, turn the speaker mark on. This screen shows Parametric Equalizer. It has 5 parameter settings. The colors of these buttons are linked with the point color on the graph. Look at the orange point. You can set on or off with this button. You can select the filtering methods here. PE, Parametric Equalizer, is selected. Here, you can input the frequency. 500 Hz is set here. Sliding this bar can increase or decrease the sound level. When making the shape of the filter, the value called the Q value is related. If it is set to 1, it'll be a gentle slope. If it is set to 10, it'll be a sharp slope. Then adjust the sound level while listening. Play back the sound. Emphasize around the middle range, the yellow point first. Lower the sound. Next, lower the sound of the green point at a little higher band next to the yellow one. You may hear the quite different sounds. Two filters are applied now. Then remove one filter and listen to the difference. When removing the high range of filter, you can hear tapping sounds. Vice versa, apply the high range of filter and remove the middle range filter. Then, not hear tapping sounds, while you can hear the rattling sounds. Get back to the original. Two filters are applied. When applying the middle range of filter, you found that you cannot hear the rattling sounds. See the middle range of frequency. It was 1000 Hz. When applying the high range of filter, you found that you cannot hear the tapping sounds. See the high range of frequency. It was 5 kHz. We set the frequency at pinpoint earlier. However, generally you don't know the frequency of a target noise. Next, we will show you how to find the frequency of target noise. Listen to the original sound first. Use this orange point this time. The x-axis is frequency. Move the point sideways to change frequency band. You are hearing both tapping sounds and rattling sounds now. Check where you can't hear these sounds. By this operation, you will find the rattling sounds no longer heard around 1 kHz. Try on and off the filter. When the filter is on, the rattling sounds are no longer heard. Then how about the tapping sounds? Slide the orange point. The tapping sounds are no longer heard around this band. Do the filter on and off. When the filter is on, the tapping sounds are no longer heard. If you want to find the frequency of a target noise, try the operation we showed. Thank you for watching.